Welcome students. Let us continue our discussion on engineering curves wherein we have till now studied about cycloids and involutes of a regular polygons such as hexagon and pentagon. In today's class we will start with how to make a involute of a circle. So the question goes like this. An inelastic string is wound round a cylinder of 70 mm diameter, keeping the string always tight. Draw the curve generated by the end point of the string. So this gives us the hint, this part, the curve generated by the end point of the string. This gives us the hint that we have to draw the involute. So draw the curve generated by the end point of the string. Name the curve. Also draw normal and tangent to the curve. Okay, so let us start with the construction part. So first of all, as it is said, to draw an involute or to draw the curve traced by the end point of the string, first of all, we need to draw a circle of given size, that is diameter 70 mm. So first making a circle of 70 mm diameter. Then we need to divide as usual the circle into 8 equal parts. Now, if you read the question, it is said that draw the curve generated by the end point of the string, and it is also written here keeping the string always tight. So first of all, we will find out how much string is required to entirely wound the circle. So basically it will be nothing but the length of the string will be equal to the circumference of the circle, which is 2 pi r. So if I calculate the value of 2 pi r, I will get, so it is 2 multiplied by pi, that is 3.14, multiplied by r, which is 35. So I am getting answer as 219.8. So what I will do is I will make a line of 219.8 mm from this point. So it is 219.8, and let us name this point as P, so that we will trace the path traced by this end point P in the entire question. Now we need to divide this line into same number of equal parts as that of the circle. So as we have divided circle into 8 parts, I will divide this line also into 8 parts by using that parallel line method, for which we will take any angle approximately 30 degrees. And on this I will mark equidistance point. So let us say if I select the distance to be as 2 centimeter, so I will make equidistance point of 2 centimeters each. 2, then it will be 4, then 6, then 8, 10, 12, 14, and 16. So this way I have marked 8 points. Now we have to join the end point of this with the end point of our circumference line. And then by using the parallel lines, we have to draw all the lines. So this way we have divided the entire circumference into 8 equal parts. Now we will give the namings. So let us say this point is 1. We will go in anti-clockwise direction. So this is point 2, 3, and so on. Now, as we have given the name to these points on the circle, we'll give the naming to the points on this line also. So 1, 2, 3, and so on. Now, after doing this part, if you remember the cases wherein we have drawn the involute of a pentagon and a hexagon, that means any of the regular polygons, then what we have done next step, we have extended the sides. Okay. We have extended all the set, for example, 1 to 2, then 2 to 3, and so on. Here, what we need to do is we need to draw tangents to each and every point on the circle. That's the difference between the construction of a involute of polygons and involute of a circle. So to make the tangents, we know that tangent is always 90 degrees. So I will keep the protector at this point and we'll measure 90 degrees. So 90 is somewhere here. We'll just mark it. Then similarly from all the points from point 2, again I will measure 90 degrees. Then going to point 3, then shifting it to point 4, then shifting to point 5, then shifting to point 6, then point 7, and then finally point 8. It will be nothing but this line only. So after marking 90 degrees, I will just join now or make all the tangents. This is tangent from point 1, then tangent from point 2, tangent from point 3, then tangent from point 4, tangent from point 5, tangent from point 6, tangent from point 7, and finally tangent from point 8, which is already there. So I'll just repeat the steps what I have done. First, we will have to draw a circle of the given dimension. Divide that circle into 8 equal parts. Then make a line equal to circumference of a circle. Again, divide it into 8 equal parts. Then mark 90 degrees from all the points. That is, if you want to draw a tangent. So we know that tangent and the radius makes 90 degrees. So I have marked 90 degrees from all the points on the circle and draw the tangents. Now come the last part wherein we have to draw the involute. So for that you need to take a compass, keep it on point 1. Again I repeat, keep it on point 1, measure the distance till point 8. In the involute of polygons, what we need to do is we need to make an arc here from this point to this point. But in this case, wherein we are drawing the involute of a circle, then we don't have to draw an arc. We just need to take the measurement from point 1 to point P and then keep this on point 1 and cut the arc on this tangent from 1. So I will just cut the arc. Okay. So again I repeat the step. Keep the compass, keep the compass at point 1. Measure the distance from point 1 to point P. Then keep the compass at point 1 on the circle, that is, it will become the center, and then cut an arc on the tangent at point 1. Now, next step. Now we'll keep the compass at point 2, measure the distance from 2 to point P, then keep the compass on the circle. Point 2 will become the center, and then cut an arc on the tangent line from point 2. So I will extend the line. Then similarly, we have to proceed further. Now we measure distance from point 3 to point P, then keeping it on point 3 on the circle will become the center, and then we have to cut an arc on the tangent from point 3. Now next, again following the same pattern, now we'll keep the compass at point 4, measure the distance from point 4 to point P, then keep the compass at point 4 on the circle, which will become the center, and then cut an arc on tangent from point 4. Then next point is 5, doing the same procedure, measuring the distance from point 5 to point P, keeping the center as 5 on the circle, and make an arc on the tangent from point 5. Then coming to point 6, measuring the distance from point 6 to point P in compass, then keeping it at point 6 on the circle with the center becoming point 6, and then cutting an arc on tangent of point 6. Then finally, measuring the distance from point 7 to point 8, and then keeping it on 7 and cutting the arc on tangent from point 7. Then we will give the names to all these points we found out. So let us say this is point P1, then point P2, P3, and so on. Now we need to join these points by the smooth curve. So starting from point P, we have to go to point P1, then from P1 to P2, then P2 to P3, P3 to P4, P5, P6, P7, and then P8. So you have to join this by a smooth curve. The curve should pass through all the points. So starting with P1, then P2, P3, P4, P5, P6, P7, and then finally terminate at point 8. So this curve, which we have drawn just now, tracing this point P, is nothing but the involute. So it was asked in the question to name the curve. So I will name the curve as involute. Then we are remaining with the dimension part now. So dimensions, two dimensions need to be given. One for the diameter of the circle, and other will be the length of the string. Now, it was also asked in the question to draw normal and tangent to any point on the curve. So starting with that part, I want your attention for the steps in constructing the normal and tangent on the involute of a circle. So step one is, as in the question it is mentioned, to draw normal and tangent to any point on the curve. So first I will take point as per my wish. So let us say this is the point on which I need to draw normal and tangent. So I will name this point as M. Next step is you have to join this point M with center of the circle with very light line. Next step is we need to bisect this line M to C. We have just now joined the line from M to center C. The next step is bisect this line MC. So for bisecting, we will use the line bisector method, in which we will keep the compass at point C, then measuring the distance more than half of this line and just make a arc somewhere here. Similarly on the other side. Now keeping the same radius at point M, we need to draw arc from this side also. So I will extend the arcs from C as it is not intersecting. Now after marking this, we will join this line and wherever this bisects the line, we will name this as, let us say, O. So again repeating the step for drawing the normal and tangent. First of all, as it is given that we have to draw normal and tangent to any point on the curve, I have selected any point on the curve and then join that point with the center. After joining that point with the center, we will get one line which is MC in this case. Now we need to bisect this line MC into two equal parts. For that, we are using line bisector method. Now, once we got this point O, now we have to keep our compass at point O and with a radius OM or OC, anything will do because both of them are same. It is bisected perfectly. So with OC or OM as the radius, you need to draw semicircle. Again, I repeat, with OM or OC as the radius, you need to draw one semicircle. Again, it will be very light. So it is like this. Then, wherever this semicircle, again I repeat, wherever this semicircle cuts the circle, which is this point, wherever this semicircle cuts the circle, this is this point, I'll mark it, this point. Now, joining this point, which we just now got, the intersection of semicircle and circle with our point M. This line we just now draw, the line from the intersection of semicircle and circle to this point M is nothing but your normal. So I will name it as N and N. And we know that normal and tangent are always perpendicular to each other. So I will keep and measure 90 degree, which is here. And now just joining this point with point M. This is the tangent. So this completes the solution in all respects, wherein we have drawn a involute of a circle along with normal and tangent to any point on the curve. Hope you have understood. In next class, we will see the same thing, but the length of the string will be shorter than equal to the circumference of the circle. In this case, the length of the string we have taken equal to circumference of the circle. In next class, we will see how to draw an involute when the length of the string is less than the actual circumference of the circle. Thank you.